Good afternoon. Hopefully my wife and kids are watching the stream at home. So hi Hun, hi Avi, hi Ezra. And of course the setup is not, the presenter notes aren't showing. There we go. So thanks to the organizers. It's really a pleasure to be here at Ruby on Rails. And as Kobe was saying at lunch, he's helped me rack up the frequent flyer miles. I'm from upstate New York, and this is the second conference in a month that Kobe organizes that I've spoken at. So he's really helping me rack up the miles there. So, small code. I just want to let this quote here sink in. It showed up on my Twitter feed as I was preparing this talk. And all of us have some file that's filled with code that we just don't want to open. That class that has comments like, "Woe to ye who edit here." The problem with this stuff is that it does live forever. It encapsulates business logic that ends up getting duplicated elsewhere. It's hard to understand, and you don't want to change it. We're going to talk about ways to avoid this situation. This talk's primarily going to focus on code at the class level and at the method level. Having small code at the class level and method level is fundamental to being able to create systems that are composed of small subsystems. I'm going to go over this initially to dispel a few concepts so that we can start with a clean sheet about what small is. I think there's a lot of problems with what people conceive of small as well as what is well-designed code. It's not about the actual number of lines, the actual amount of code you write, but how it's organized. Fundamentally, writing small code is a design discipline because that's the only way you can write small code, is to use design and refactoring. So this is really about design and refactoring because that's how we get to small code. We don't just sit down and have small code from scratch come out of our heads into our editors, and it's all perfectly designed, laid out in the perfect way we want it to be. We have to design and iterate our way to get there. So what does small mean? It's not about total line count. Well-designed code typically has more lines of code than badly designed code. The simple overhead of declaring methods and declaring classes is going to actually raise the line count in what I consider small code. It's not about method count. You will almost surely have more methods in well-designed code than you will in badly designed code. I love the quote that computer science is the discipline that believes that all problems can be solved with one more layer of indirection. That's from Dennis de Bruler. And by adding more methods, we add indirection, which allows us a lot of flexibility in how we compose our systems. So as we create small code, we will actually increase the number of methods in the code so that we can separate the what from the how, the intention from the implementation, and raise the level of abstraction. It's not about class count either. Well-designed code will almost definitely have more classes than what I call undesigned code. Although I've seen some cases of over-abstraction, I find that that situation is atypical. Small code is definitely not about decreasing the number of classes in your system. Small code that is well-designed will typically have more classes in it than poorly designed code. So, what do I mean by small? Small methods are the foundation of writing small code. Without the ability to decompose larger methods into smaller methods, we cannot write small code. In classical object-oriented languages, the fundamental unit of code is the class. Yes, some languages have packages or modules or other types of namespaces, but in the end, the class is the fundamental unit of code organization. To write small code, we have to be able to decompose large classes into smaller classes and extract responsibilities and separate them based on higher level abstractions. It's important that our classes are small because small classes are what lead to reusability and composability. So, why should we strive for small code? The big one is your software requirements will change. If your app succeeds, which you want it to, the environment in which it needs to work is going to change. Software must be amenable to change. Any system of software that's going to have a long life will change significantly over that time. Small code is simply easier to work with than large, complex code. If the requirements of your software are never going to change, you can ignore everything I have to say. But if it's going to change, you should pay attention. Raising the level of abstraction in our code is one of the most important things we do to create readable and understandable code. All good design really is driving toward expressing the ubiquitous language of your domain in your code. The combination of small methods, well-named, and small classes, well-named, help us raise the level of abstraction and express higher-level concepts. Small methods and small classes force us to use composition. Thankfully, small classes and small methods compose well together. As we compose instances of small objects together, our systems will become message-based. In order to build systems that are based upon message passing, we have to use delegation. And all of this is to enable future change. So, the challenges. When we start composing objects together, it forces us to manage our dependencies. Managing dependencies is one of the most important aspects of object-oriented design. It's a fundamental enabler of small code. One of the largest goals of using small code is to be able to be context independent. If you're using test-driven development today, your code already needs to run in two contexts: the production context and the test context. Well-designed object-oriented software separates the how we're doing something from the thing that sets up and creates the context within which the work is done. Separating our code from depending on the context in which it runs, it helps us with testing and reuse through composition. And if your testing is hard, it probably means that your code is not context independent. The example I have, if you've ever mocked something like some class, .anyInstance, .stubs, some method, or the equivalent, you're not context independent. You're just faking yourself out. So the goal is small units of understandable code that are amenable to change. Our primary tools are extract method, extract class, and move method. Longer methods are harder to understand than short methods. Most of the time, we can shorten a method by using the extract method refactoring. And once we have a set of methods that are coherent around a concept, then we look to extract those into a separate class and move the methods to the new class. And we're going to see that as we go on. So, we're going to look at some code. Coming up with an example to use in a talk is one of the hardest things I've found to do. You need a domain that's small enough to understand quickly, but is not trivial to the point of silliness. I like to have examples that you can kind of get your teeth into. I'm going to be using the example of a command line option parser that handles booleans and strings to start with, and then we're going to see where the future requirements take us. At the command line, I want to be able to run some program, pass it some arguments, in this case a -v and a -s foo. In this example, the v is a Boolean option, and the s is a string option. In my Ruby program, I want to define what options I'm looking for using this simple DSL. We knew a command line options object with the argv, which are the arguments from the command line that you get in Ruby, and then pass it a block to be evaled to set up the options. In this case, the v, which defaults to a Boolean if there's no option there, and the s to a string. And then I want to be able to consume it like this. I can check that the options are valid, and I can get the values of the options that were on the command line. Putting it all together, I can pass the options on the command line, I define the options I'm using, the DSL, and then I validate and I can get the values out in my code. That's the starting point that we're going to implement here as we go along. So this is the class that does it. It's not too big, 31 lines, but I pretty much sat down, just did this straight through, in what I consider a non-OO style. It has issues. Starting out, it's got one big method that's definitely large, has one that's looking on the verge of being large, has a lot of conditional complexity, and as we'll soon see, it's not very amenable to change. So we're going to take a look at this piece by piece so you know how it works. This is my initialize method. We create a hash to store the options, store the array of args in @argv, and then eval the block to set up the options we're looking for. And remember, this is the block that's getting evaled in there, so you can see how it hooks together. This method is actually the whole implementation of the DSL. We store the options in the hash that we created in the initializer, keyed on the option flag, and we just store the type, Boolean or string, as symbols. And again, just so you can remember, that's the DSL. It's pretty simple. The keys of the hash are the options that can be passed on the command line that we'll look for, and the type is the value. Or excuse me, the value is the type, either string or Boolean. And that's enough to go in and get the stuff out of the argv. This is the valid method. And here we iterate over the options, looking for the ones that are strings, and checking to see that if they are present, that they have content. Because you can't put a string option on the command line and not give me some content. That's not valid. And currently, string options are the only ones that we need to validate. Boolean options really don't have a validation. Either they're simply there and they're true, or they're not and they're false. And this is the value method. This one does a lot of stuff. For now, we're just going to pretend this is a black box. This is by far the worst method in the code so far. This is also the strong indicator that we're missing something, and we're going to come back to that. But everything is spec'd, and the specs pass. My code does work. So we know our code has some methods that have problems. What makes a good method? And I got to say, I did credit here. A lot of this material is based on clean code from Robert C. Martin, Uncle Bob. So I just got to give that shout out to him. And I like this one, this quote. This hit me when I was preparing, that the object programs that live the best and longest are those with short methods. The operative word being best. Not those ones where you don't want to open the file and look at them. We want to open these because they're good. So the first rule of methods is do one thing, do it well, and do only that thing. Does that mean our methods should be one line? How do we determine if a method is doing only one thing? And for that, you see rule number 2. You want one level of abstraction per method. Use descriptive names. I can't tell you how many times I've looked at code and seen a comment on a method that was a great explanation of what it did, that if you took the words, bang them together, put underscores, they'd make a fantastic method name. Yet, the method's name is something else that really doesn't say what it does. Name your methods well. And the fewer arguments, the better. My goal is 0 arguments as much as possible. I can tolerate 1, but once I'm at 2 or more, I'm looking for a missed abstraction that can be extracted. A class that has a method that takes a lot of arguments, it's hiding something. It's hiding an abstraction that's probably yearning to be free. Separate queries from commands. Your method should do something to an object or should return something about that object, not both. When you do both, it's just too confusing and hard to reason about. And most importantly, don't repeat yourself. Once you start repeating code, you will have multiple different versions of business logic scattered around the application, and over time, they're going to diverge. So let's look at some methods. Here we have repetition. Both the valid and the value are digging through the argv array to find the option from the command line. This is a perfect candidate for an extract method refactoring. We have magic constants scattered around. They're not actual violations of the rules of methods, but they are a strong indication that we've missed something. We're violating other rules. I think it's hard to say that either one of these methods is really doing one thing, and that all of the code is at the same level of abstraction. Valid is digging into the argv array. Value is figuring out different types and how to return their values. They've got a lot of knowledge built into them. Now we're going to start by cleaning up this code, making it small. We're going to eliminate some of the repetition with an extract method refactoring. And I'm just going to go over how that works. The extract method refactoring entails moving part of a method into a new method with a descriptive name, and that's very important, and then calling that new method. This refactoring helps us keep the level of abstraction consistent in the method that we are extracting from. Here we have one expression in our method that is at a high level of abstraction, then two lines that are at a low level of abstraction. So we move the less abstract code to a new method with a descriptive name, then call the new method. This results in the old method having a consistent level of abstraction. So back to our command line options class. Both valid and value are digging through the argv collection to find the option values. So we're going to extract that code and get the raw values out of the argv down here. Then we're going to call the method from where the original logic was extracted. Now the code still has issues. There's referencing the option type to see if it's a string. Then there are the magic constants used to dig into the argv element to get the content out of the option. There are other things we could do to improve this non-OO code. I could easily extract a string valid method. I could also extract a method for getting the content out of the string option, and one for a Boolean option, but it misses the point. Once we had the string option, we should have been looking for a duck type. So let's try those extractions and see what the code looks like before we go down the duck type road. Here's the code with the low-level code replaced with the extracted method calls. The code's a little bit more self-explanatory. We have string option valid, it says what it does. It tells you if the string option is valid. We have extract content, tells us what it's doing. It's getting the content out of the option value. The naming of the method is very important. Their names say what they do. But overall, I'm not happy with this code. It's more explanatory, but it's not small yet. These methods are large because we've missed something. But if this is all I had to do, I might leave this at this point, except I know over time requirements change. And my buddy comes to me and says, hey, I really like your command line option library, but I want to do some integers now. I could drive down the procedural non-OO path that I've been on and complicate the valid and value methods by switching on the type and digging into the argv elements to find the value. But this is our chance to make a change and make our code more amenable to change. But to illustrate this, because I'm sure some of you have done this and you've gone down this road, not realizing that there is an alternative, we're going to show that. So here's the procedural non-OO code version of it. Is it horrible? No. Is it small? Definitely not. The class is growing due to changed specifications, and the valid and value methods are being changed in lockstep. This is a sure sign that we've missed an abstraction or a duck type, in this case, the option abstraction. And those methods are getting big and complicated and now doing even more things. And when you have 2 methods or 3 methods in a class that change in lockstep, you're missing something. You're missing an abstraction. Code does have tests. They all passed. That's a good thing. But it's not satisfying. We're suffering from large methods and complex conditional logic. Now, I want to call your attention to some of those patterns that tell me I'm missing an abstraction. We see the checking of the option type and the divergent behavior based upon the option types. Don't reinvent a type system. Ruby has one. If you have ducks, let them quack. In our case, the options are our ducks. And I'll bet there are ducks in your code yearning to be free. And just for further confirmation that we are dealing with an abstraction or a duck type, we see the testing again in the value method. Hidden inside the value and the value methods is actually a case statement. And so here's the case statement version of these, so you can see it more clearly. Where we're casing on the option type invalid. And here again, we clearly see the duck type casing on the option type in the value method. Now, I would guess that if I was writing this, I probably would have started down the OO path as soon as I had that second option type. I just wanted to illustrate the non-OO mess you can get yourself into if you keep riding the horse until it's dead. My dad had a saying hanging on the wall of his office: when the horse is dead, get off. Sometimes we don't realize the horse we're riding is dead, and it's time to take a fresh look. So since classes are the fundamental organizational unit of classical object-oriented languages, it's time to look at what constitutes a good class, because we're missing some classes. These principles are going to lead us to be able to write small classes. Classes should be small, and to make them small, we assure that our class has one responsibility. And the way I do that is talk to the class. Ever hear talk to the rubber duck? Anybody have a stuffed animal or a duck on their desk to talk to explain a problem to, so they can tell you what's wrong? Talk to your classes. Find a good name. Isolate the responsibilities. Find properties or attributes of those classes that go together. This set of methods is using these attributes. This set of methods is using those attributes. And they don't seem to be crossing over. You probably have two concepts that are in one class. And the tools are extract class and move method that we're going to use here. So, single responsibility, cohesive properties. The thing I drive for, and this is where small to me really makes sense, is a small public interface. Hopefully, I want that interface to implement a single use case. And if possible, the primary logic is expressed in a composed method. So, let's imagine we have a clean sheet and we can write the command line options the way we would have with the knowledge that we have now, that it needs to support Boolean, string, and integer options. Here's what I'd write. It's 28 lines long. The class is cohesive around its properties, which are the argv and the options. It has a single responsibility: manage our options. Depending on what height you want to view it, you could potentially extract a builder class, but I'm happy with where this is now, and it sure has a lot fewer responsibilities than what we started. It has a small public interface, just two methods, the valid and the value method. And it has no hard-coded external dependencies yet. We could mess it up and introduce those, but we're going to avoid that. Another interesting characteristic of it is that there are no conditional statements in this class, and we're going to keep it that way. In Sandy Metz's 2009 Garuko talk on the solid principles, she said something along the lines of: a conditional in an object-oriented language is a smell. That's a really powerful statement. I don't think Sandy was saying we can't use conditionals in our code, although I spoke with her earlier and she says we can get rid of them all. But I think she was driving at occasionally we use conditionals to hide our abstractions and to hide our ducks. And the first time I saw Sandy's talk, I don't even know if I heard her say this. Then I'm rewatching it, I heard it and thought, really? Then as the years have gone on, I've realized she's right. The initialize and option methods are unchanged from my previous implementation. We still store the options in a hash. My valid method simply asks all the options if they're valid. And the value method simply looks up the option in the hash and asks it for its value. Now we are left with the build option method. It's the only thing left to implement in our command line option. Now, before we start extracting the Boolean string and integer option responsibilities for class, let's talk about how we deal with dependencies, because we could create a dependency mess right now in this code. Deal with dependencies by using dependency inversion and depending on stable abstractions. And don't confuse dependency injection with dependency inversion. Dependency injection is just one way to achieve dependency inversion. And dependency inversion means we want to depend upon abstractions, not concretions. That's all it is. I could go down the case statement road again and check the option type and instantiating the appropriate type of object. This is an example code from a previous version of the library experimented on. I'm not going to do that because that would tie our command line option class to the concrete types of our options, creating a hard dependency between the command line options class and the various option classes. Instead, I'm going to use a little bit of the dynamic Ruby magic to instantiate those objects for us using naming conventions. For string, we're going to have a string option class. For booleans, a boolean option class, etc. This very simple change takes our command line option class from depending on concrete implementations to depending on an abstraction, options. This is dependency inversion from the solid principles in practice. If I were working in a statically typed language, I would move the manufacturer of the options out to a factory class and isolating them from the command line options. And you'll see why later. Because that insulates command line options from future change due to new option types. In our case, we've inoculated our command line options class from needing to change to support new option types. At this point, this class should be closed for modification. Then we need to move the logic for the various option types to the appropriate option class. Here are the various option classes I came up with. The logic for how to do validation and extract values was already contained in the original source code from our command line options class. I kept that aside for reference as I was doing this. Notice all the methods, other than the initialize, take no arguments. There's no argument passing here because they're cohesive around their properties. I would likely extract a superclass for string option and integer option called option with context. It just didn't fit on the slide because they both require content to be present and need to extract the content from the raw value. They have a lot of commonality, so you pop out that superclass. But I'm going to leave that as an exercise for you to try at home. So on the left, we have the original valid and value methods from our command line options class. On the right are the new string option and integer option classes. As you can see, the process of creating the option classes on the right was simply picking apart and disassembling the old command line options class, moving the logic to where it belongs. Using a combination of extract class and move method refactorings, we've really cleaned up command line options. All the nasty logic that was in command line options has been moved into the various option classes using a combination of that extract class and move method refactorings. And to create the specs for the various option classes, I moved the corresponding section from the command line options to the spec to a section for each one of the options. And then I worked them from red to green. It's very important. Always work from red to green. So how do we isolate abstractions? And I like to say, how do we separate the what from the how? You want to move from code that looks like this to code that looks like this. The original method contained all of the how. The second method says what we want done for us. I hear a lot of talk about tell, don't ask. Then last week there was a new blog post that says ask, don't tell. I'm confused here. Personally, I think we should be distinguishing between what we want done and how we want it done. And those should probably be in two different places. Again, we move from code that looks like this to code that looks like this. We move the nitty-gritty details of your code out to the leaves of the system, to the classes that are on the edge. So when we're done, what our command line option class looks like. These are our public methods. provides a very small surface, but it fulfills the use case. This is the private implementation cruft. It's necessary, but no one really needs to go poking around in there. That's why it's private. In the end, this is the sum total of the implementation of our public interface, and it's all delegated through composition. We're done. Well, not really, because we've gutted the test suite of command line options, moving everything to the various option class tests. So what do we test for command line options? And this is where I have occasionally gotten stuck. For certain, I'm sure that we need to test that if any option is invalid, then the options are invalid, and retrieves value from the options. That's the real behavior of this thing. Get me a value, and is it valid? What I'm not certain about is whether we should test what type of option class it builds based upon the option type. But here's a brief spec. See, at this point, to me, I look at the command line options class as a collaborator and a coordinator. It sets the context. The option classes are independent. We can test them independently. We could use them independently of this class also, because we've delegated all the business logic down into those option classes. That top-level class, it really has no logic in it anymore. So these two examples, it is valid if all options are valid, and it is invalid if any option is invalid. I'm absolutely certain those should be there. That's the contract. The example that it builds objects, I'm not so sure about that, but I'm okay testing that because I consider this part of the documentation, and then I settled on testing that when I put a string option in, I get a string option class back, an integer option class, and a Boolean option class, because I want to document it, because if you look at that one, the classes aren't there. It's all by convention and loosely coupled. And in the process of making the specs pass, again, I commented out the code, and I dreamed up the code. Then I went back and put it in line by line to make them pass. Because like I say, you always want to be working from red to green. Then the guy shows up and says, hey, can I do arrays? And this is where the magic really happens. Because to implement this new requirement, I only need a new class. So I write a spec, make it fail, then create the class. In this one, I do have that superclass of the option with content. This was a little further down the road. And all I had to do is implement the value method, and now my command options is supported with arrays. That's it. That command line options class is closed to change, but it's still amenable to future needs and requirements because we have divorced it from concrete implementation dependency. And it just works. Now we're done. If they want more options, let them implement the option classes, because now it's easy. They need a valid method and a value method. My name is Mark Menard. My company's Enable Labs. We do development training, mentoring. Let's have a beer and talk.